Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Simple Network Management Protocol, more commonly known as SNMP, is one of the core technologies used in managing and monitoring modern networks. It allows centralized visibility into device health, performance metrics, and fault states. By using SNMP, administrators can collect data from network infrastructure such as routers, switches, firewalls, wireless controllers, and servers, all from a single platform. This capability reduces the need for manual checks and helps network teams respond more quickly to performance issues, outages, and hardware failures. For anyone pursuing the Network Plus certification, understanding how SNMP functions is essential for mastering network monitoring objectives and answering protocol-specific questions on the exam. SNMP has evolved over time, with different versions offering various levels of capability and security. Version 1 is the original and provides only basic features, such as retrieving and setting values. It has no support for encryption or authentication. Version 2C improved on version 1 with more efficient data handling and better performance, but it still lacks any built-in security. Version 3 introduced significant improvements, including support for authentication and encryption. Because of these enhancements, version 3 is recommended in secure environments. On the exam, you may be asked to compare the features of these versions, or choose the appropriate one for a given scenario. In SNMP versions 1 and 2C, access control is handled using community strings. These strings act as simple, shared passwords between the SNMP manager and the device being monitored. The most common default strings are public for read-only access and private for read-write access. These strings are sent in clear text and offer no encryption, which makes them vulnerable to interception and guessing. For this reason, using version 1 or 2C without changing the defaults poses a security risk. Understanding how community strings work and why they should be replaced is important both for exam questions and for securing network infrastructure. SNMP operates through a manager and agent model. The manager is typically part of a centralized monitoring system that collects and displays data. The agent runs on the network device itself and responds to queries or sends alerts. The agent uses a data structure called the Management Information Base, or MIB, which defines all the values that can be monitored or configured on that device. When the manager requests information, it queries the agent using specific object identifiers, or OIDs, that point to the desired metrics. This structure allows for consistent and standardized communication between different vendors and device types. Management information bases are organized using object identifiers. An object identifier is a numeric string that uniquely identifies a piece of information about the device. Each OID corresponds to a specific parameter, such as processor usage, fan status, memory utilization, or interface state. When a manager wants to retrieve data, it sends a request for a particular OID. The agent reads the current value and responds. This structure also supports setting values, such as enabling an interface or adjusting a threshold, although this is less common and typically restricted to read-write configurations. SNMP traps and notifications are used when a device needs to send an unsolicited alert to the manager. Unlike polling, where the manager initiates contact, traps are initiated by the agent. This allows for real-time alerting when events occur, such as a link going down, a temperature exceeding a threshold, or a configuration being changed. Traps improve responsiveness by eliminating the delay between polling intervals. Devices can also send inform messages, which require acknowledgement from the manager, making them more reliable than traditional traps. On the exam, understanding the difference between polling and traps is key. Polling is another core mechanism of SNMP operation. In a polling setup, the manager sends requests to the agent at regular intervals to collect updated information. These queries might include statistics like bandwidth usage, interface status, memory availability, or system uptime. Polling allows for historical tracking and trend analysis, but frequent polling can add load to both the devices and the network. Administrators must choose appropriate polling intervals based on the importance of the data and the impact on system resources. Excessive polling of large MIBs can lead to performance degradation. SNMP uses specific ports for its operations. Polling requests and responses occur on User Datagram Protocol port 161, while traps are sent from agents to the manager using User Datagram Protocol port 162. These ports must be allowed through any firewalls or access control lists between the manager and the agents. If the ports are blocked, polling and trap messages will fail, causing monitoring blind spots. Being able to recall which ports are used and how they relate to manager-agent communication is a common question format on the certification exam. Security is one of the most important considerations when using SNMP. Versions 1 and 2C are vulnerable because they rely on community strings sent in plain text, which can be intercepted or guessed. Attackers who gain access to these strings may read sensitive data or modify settings if write permissions are allowed. To mitigate this risk, version 3 should be used whenever possible. SNMP version 3 offers encryption, message integrity, and user-based authentication. In addition to using secure versions, access should be limited to trusted IP addresses, and logs should be monitored for suspicious activity. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Configuring SNMP on a device involves multiple parameters that control how the device communicates with the management system. Administrators must first choose which version of SNMP to enable, with version 3 being the most secure due to its support for encryption and authentication. Once the version is set, community strings or user credentials must be defined, depending on the version in use. Devices must also be configured to allow queries only from trusted hosts to prevent unauthorized data access. For alerting, trap destinations must be specified, allowing the device to send real-time alerts to a management server when predefined events occur. Finally, the device must expose the correct management information base entries to ensure that only relevant data is made accessible to the manager. SNMP is typically integrated into network monitoring systems, often referred to as network management systems. These platforms collect data from devices using polling and receive traps for real-time alerts. They then process and display the data in the form of charts, graphs, and status dashboards. Through these systems, administrators can view performance trends such as bandwidth usage, CPU load, and link status. Most platforms also allow for alert thresholds, so that if a particular metric exceeds a defined value, a notification is sent to staff. Reports can be generated for historical analysis, capacity planning, and compliance auditing, making SNMP a cornerstone of proactive network management. SNMP and syslog both play important roles in monitoring, but their approaches are different. SNMP is structured and query-based, relying on object identifiers and management polling to retrieve specific values. It is designed to provide metrics and operational data, such as the number of packets on an interface or the temperature of a chassis. Syslog, by contrast, is unstructured and passive. It sends free-form messages about events, errors, or configuration changes without requiring a request from the manager. Both tools are commonly used together. SNMP provides quantitative metrics, while syslog delivers textual event messages. On the exam, distinguishing between these methods is key to understanding their respective use cases. SNMP is valuable not just for monitoring, but also for troubleshooting network issues. If a switch port is flapping or a router interface is down, SNMP polling or traps can identify the problem before users report it. Bandwidth saturation can also be detected by monitoring throughput counters, while abnormal temperature readings can signal a cooling issue. Hardware health metrics like fan speed and power supply status are exposed through specific object identifiers, allowing technical teams to act before failures occur. This ability to pinpoint the root cause quickly makes SNMP an essential component of any diagnostic toolkit. As helpful as SNMP is, it can introduce overhead if not carefully configured. Frequent polling, especially across many devices and large MIB trees, can generate significant traffic and processing load. This can lead to slow responses or missed data points. To optimize SNMP usage, administrators should carefully balance the frequency of polling with the importance of the data being collected. Critical metrics may be polled every few seconds, while less important values can be collected hourly. Additionally, devices can be configured to expose only the necessary object identifiers, reducing the dataset and improving efficiency. In secure environments, enabling SNMP requires careful planning to avoid introducing vulnerabilities. Administrators should use read-only access whenever possible to prevent unauthorized changes. Default community strings like public and private must be changed, as they are widely known and often targeted by attackers. Restricting which IP addresses can issue SNMP requests limits exposure and ensures that only trusted monitoring systems can interact with the devices. When available, SNMP version 3 should be used exclusively, as it provides encryption and robust user authentication. These steps are essential for protecting network infrastructure while still gaining the visibility SNMP offers. SNMP also plays a major role in network documentation and mapping. Many monitoring systems use SNMP to perform device discovery by scanning ranges of IP addresses and querying devices for identification information. From these responses, the platform builds an inventory that includes device types, names, interface lists, and uptime. Some tools even use this information to generate topology maps that visually show how devices are connected. This level of automated documentation is useful for both operational management and compliance reporting, reducing the need for manual tracking of assets. On the Network Plus exam, you should expect to answer questions that test your knowledge of SNMP versions, port numbers, and operational behavior. You might be asked to match the correct version to its features, such as authentication or encryption, or to choose which port number supports trap messages. Scenario-based questions may describe an issue where traps are not reaching the server, or where community strings are misconfigured. Understanding the distinction between polling and trap-based alerting, as well as knowing how to secure SNMP traffic, will prepare you to answer these questions accurately. In conclusion, SNMP is one of the most important protocols used for network monitoring and management. It provides centralized visibility, supports both polling and real-time alerts, and enables performance tracking across all major device types. When implemented correctly using secure configurations and efficient polling strategies, SNMP enhances network reliability and helps detect issues before they escalate. For the certification exam and for success in managing complex environments, mastery of SNMP's roles, ports, versions, and behaviors is a must. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.